So that last lesson with the graphs wasn't too bad, but going into the algebra gets sometimes a little confusing, but honestly it comes back to this main point. So right here, what causes the vertical asymptote? So we're going to take a look. We're going to look at the calculator. We're going to go ahead and try to find the limit as x goes to 0 of 1 over x. We know 1 over 0 is undefined, so we can't just plug this in. So we're going to go ahead and try to estimate it using a calculator. So I'm going to try with negative 0.1. So if I put that in the calculator, 1 divided by negative 0.1 is negative 10. If I try 1 divided by negative 0.01, I'll get negative 100. And you could see this. Check it out. If I try something closer to 0, it'll be negative 1,000. Or the next one, negative 10,000. Negative 100,000. So what's going to happen is we get closer and closer to 0. We're basically taking 1 and dividing it by like a super, super small number. You know, I can fill in this side. This is going to be 100. This is going to be 10. We know that. 1 divided by this, how many times does 0.0001 go into 1? How many times can we add this number to eventually get to 1? And that answer's 10,000 times. So you could see as this number gets smaller and smaller and smaller on the bottom, 1 divided by that super small number is going to get really, really big. And that's a very important math concept. And eventually it's going to be infinity, right? If we have like 1 over 0.0000000000000, and you can see how many zeros, I could put so many zeros, eventually this number is going to be blowing up to infinity. So how is this going to help us? So what we're going to do with this lesson, well, I didn't really answer this question. So this one's approaching negative infinity, it's blowing up, and this one's approaching positive infinity. So we're going to kind of take this numerically. So here's our function f of x and we're checking out the limit as x approaches 1 from the right and from the left. So let's go ahead and break it down. So left-hand limit, I'm going to plug in, and let's just say you try plugging in direct, right? You plug in a 1, you get 1 over 0. So you're stuck with that form, a over 0, that vertical asymptote form, right? Remember, 0 over 0 is undefined, and we look at it further like we did in the past. But this is different. If you plug in the 1, you get a number over 0. This is the vertical asymptote. Remember, 0 over 0 is indeterminate. We probably have to factor or do the conjugate, one of those other methods if we run into that. But if we end up with a number of 0, it's a vertical asymptote. So for what we're going to do is we're going to test a number really, really close. Instead of writing left-hand limit, let me just go ahead and write it out so we can see it. Limit as x is approaching 1 from the left of f of x. So I know that it's a vertical asymptote. So what I'm going to do is it's either going to positive infinity or negative infinity. It's going to one or the other. So if you have a vertical asymptote case like we do here, then we know it's going to one of the infinities. So we're going to test a number to see which one. So what I'm going to do is I'm going to plug a number really close to 1 from the left. It doesn't have to be super, super, super close, but it needs to be relatively close. And the reason why is we're testing to see if we get a positive or negative. And it is possible that, you know, as we approach 1, it could be negative. If you pick a number too far from it, it could be negative and then turning positive, like negative in this region, turning positive. So we want something pretty close to it to test it out. So now 1 over, I'm going to pick 0.9. So I'm going to have negative 1 over 0.9 minus 1 is negative 0.1. But it is going to be squared. So we have a negative, and then it's a positive over a positive. So think about this. We're just thinking of the sign. Is it going to positive infinity or negative infinity? So a negative positive is just a negative, right? So the limit as x approaches 1 from the left is going to be negative infinity. It's not that the limit equals that. Well, yeah, we might as well just stick to that. It'll be fine. Being picky from the notation, not that great though, right? So let's look at that limit as x approaches from the left is negative infinity. We see it here, and we see it here. So now we're down. We limited it to the others. So let's look at the limit from the right. So pick a number instead to the right of 1. So that would be 1.1. In this case, I get 0.1 squared. So a negative positive over a positive, because anything squared is positive, right? Just like we saw up there. So that's going to be negative infinity as well. So which answer is this going to be? So this one's out, positive infinity. So we're going to answer with D. Now it's interesting, since these are actually both going to the same infinity, we could say the limit as x approaches 1 of f of x equals negative infinity. We could say, instead of just saying does not exist. I mean, technically that's unbounded, right? So we could say it doesn't really exist. Trying to take a look at these to see what we should do. So I think it's the same idea here for these as well. I mean, this one's very, very similar to what we just did. But, dealing with the natural log, so the limit as x approaches 3 from the left of g of x. So, once you've identified that, hey, we have a number over 0, which is what would happen here, right? If you plug in a 3, we would get 3 over natural log of 1, so a number over 0. So you're like, okay, this is a vertical asymptote. So we're going to test it from the left and the right. So I'm going to plug in a number to really close to 3 from the left, so 2.9 goes in for x. And if you need to, you can use a calculator for natural log of 2.9. Minus 2, right? And I get a negative. So it's a positive over negative. Which is going to go to negative infinity then. Same idea, limit as x approaches 3 from the right. So I'd plug in a 3.1. And 3.1 is positive. Over on the bottom, let me just change this to a 3.1. And that's a positive. So this is going to positive infinity. So as we approach 3 from the left, it's going to negative infinity. So let's see which one of those. Let's see it here and here. And then which one has our limit from the right going to positive infinity? That would be right here. So we're going to answer with B. And same idea with this one. You just go through that same process. Check it from the left, check it from the right. Be careful with that negative in the front. But it's really not too bad. You're just going to have to break it down and look at it from each side of the asymptote. And kind of picture what we did before, right? Picturing, here's our vertical asymptote. Let's check it from the left, check it from the right. By picking a number really close, because we're not able to, it's not like we have 0 over 0 where we can factor and cancel or something. We're stuck here with a number over 0, so we know it's a vertical asymptote and we have to inspect it further.